Hello, I'm Urania, the Greek muse of astronomy, and I'd like to help you with your revision of the astrophysics option in the AQA A-level physics specification. You may also find the following book useful: The A-level Astrophysics Workbook, by Dr. G.K. Fox, exclusively available in the Kindle store. It also happens to have a picture of me on the front. In this video I will review Once the Sun had condensed out of interstellar gas and dust, it eventually had sufficient mass to become a protostar, which is a type of red giant. As the protostar contracts further, the core pressure and temperature increase sufficiently for the star to begin fusing hydrogen in its core. It has now become a main sequence star. It will remain on the main sequence for several billion years, until hydrogen fusion ceases in its core. With insufficient hydrogen fusion taking place in the core, the star contracts. The core pressure and temperature increases sufficiently for helium fusion to occur in the core, causing the star to expand and cool. It has become a red giant. Eventually the star runs out of material to fuse, and it collapses. Becoming smaller and hotter, the star is now a white dwarf. With no more nuclear energy production in the core, the star will continue to cool and become smaller, eventually becoming a red dwarf, and ultimately, a black dwarf star. The evolution of a Sun-like star can be shown on the Hertzsprung-Russell diagram. Starting with a red giant protostar, the star contracts until it becomes a main sequence star. Once nuclear hydrogen fusion ceases, the star expands and cools, becoming a red giant. Eventually the star runs out of material to fuse. It collapses, becoming a white dwarf star. Here is an example question. Here is a model answer. As a main sequence star, the Sun is stable because the inward force per unit area, or pressure, due to the weight of the star, is balanced by the outward force per unit area, due to radiation from nuclear fusion. When nuclear fusion ceases, the radiation force is reduced. There is now a net force acting towards the center, and the core only of the star collapses. As the pressure and temperature in the core increases, helium fusion occurs. The outward radiation force per unit area now exceeds the inwards weight per unit area. The star expands until the pressures are balanced. The star is now a red giant. Thank you for watching.